Hey guys, this is 1.6 part 1 over rational expressions. So what is a rational expression? It's a quotient or a fraction made up of two polynomials. So you're going to have a polynomial in the numerator and in the denominator. To simplify a rational expression, you first want to factor the numerator and the denominator. Then you can divide out, you could say cancel, but divide out is a better way to say that. Divide out factors that they have in common. So let's see how that works here in a second. Note, you can only divide out factors which are being multiplied. Factors are being multiplied. So just like 2 and 3 are factors of 6 because when you multiply them, they give you 6. But not terms which are being added. So terms, those are things that are being added or subtracted, like if I did 2 plus 3 equals 5. So you can only cancel or divide out when they are factors which are being multiplied. So I've got a little illustration that will hopefully help you remember that. Smiley face, these two are being multiplied, therefore I can cancel the x minus 1. The x squared is not being multiplied. We've got x squared minus 4, and on the bottom x squared plus 7. So those are terms. And you cannot cancel them in the numerator and denominator, only factors. Okay, so that's why I've got a really sad face over here. If I see you do this, that will be my face. Okay, so let's try simplifying. Step 1, we want to factor the numerator and denominator. So on the top, you see I can take out an x, leaving me with x plus 5. And in the denominator, I can take out an x there as well, leaving me with x plus 7. Okay, so now I've got two factors in the top and the bottom, x times x plus 5, x times x plus 7. You see the x appears on the top and the bottom, so x divided by x is 1. They cancel. Okay, so that leaves us with x plus 5 over x plus 7. And that's how that works. All right, let's try number 2. Factor the numerator and denominator. In the numerator, I see a GCF of 6x. That leaves me with 2x minus 5. And in the denominator, you should recognize the difference of squares here. So we can factor that by taking the square root of both terms. That's going to be 2x minus 5. And don't forget 2x plus 5. All right, so now we can cancel the factors that appear in the top and the bottom. 2x minus 5 divided by 2x minus 5 cancel. That equals 1, so they do cancel. And so you're left with 6x on the top and 2x plus 5 on the bottom. All right, number 3. Factoring the numerator. So on this one we have a trinomial, but there's a leading coefficient of 1, so we don't have to do it by grouping. We need two numbers that add to 10 and multiply to 25. Oh, I just noticed. This is a perfect square trinomial. 1 is a perfect square, 25 is a perfect square, and as it turns out, this one will factor into x plus 5 squared. You could have also gotten that by just saying two numbers that multiply to 25 and add to 10 are 5 and 5. Therefore, this factors into x plus 5 times x plus 5. which is the same thing as x plus 5 squared. Okay, in the denominator, two numbers that add to 9 and multiply to 20. That would be 4 and 5. So x plus 5 times x plus 4. Okay, so now I've got two factors in the numerator, x plus 5 times x plus 5. And then I've got x plus 5 and x plus 4 in the denominator. So since x plus 5 appears in the top and the bottom, I can cancel or divide out one x plus 5. But that's not going to cancel both x plus 5's in the numerator. That's just going to divide out one of them. So you can change this exponent to a 1. Okay, so just one of them gets canceled. If it makes more sense, you could write x plus 5 twice in the numerator like this, and then just cancel one of them. Notice that you have one left. All right, so I've got x plus 5 over x plus 4. All right, number 4. So on this one, we've got a little bit more challenging factoring to do in the numerator. So I'm going to write that one down here, actually, because I need just a little space for it. So since we have an a that does not equal 1, we'll want to multiply 2 times negative 2 to get our AC. That's negative 4. So we're looking for two numbers that add to negative 3 and multiply to negative 4. So that's going to be 1 and negative 4. So you will split this middle one up. So I get 2x squared plus x minus 4x minus 2. And now we'll factor by grouping. Group the first two, group the last two. Factor out the GCF for each group. Okay, we've got our matching terms there, so we'll factor that out, 2x plus 1, our matching factors, and then x minus 2. All right, so all of that was just to factor the numerator. That will happen sometimes, where you have to do a little bit of work to factor the numerator or denominator. Okay, and then the denominator, two numbers that add to negative 5 and multiply to 6. That would be negative 6 and positive, no. Let me write this one out. So we've got, x squared minus 5x plus 6. This one's a tricky factoring one if you try to do it in your head. So they need to multiply to positive 6 and add to negative 5. So your options are 1 and 6 and 2 times 3. Well, they need to multiply to positive 6, so they have to have the same sign. So I can't use the 1 and negative 6 because that would multiply to give me negative 6. I can use negative 2 and negative 3 though, and that will give me negative 5, and when they multiply, they give you positive 6. Perfect. So x minus 3, x minus 2. Okay, now that we've factored the numerator and denominator, we can cancel the factors that appear in the top and the bottom. So x minus 2 divided by x minus 2, that cancels. Your answer, your simplified rational expression is 2x plus 1 over x minus 3. All right, so just a little more challenging factoring in that last one, but hopefully that made sense. All right, next page, we are going to look at multiplying rational expressions. So to multiply rational expressions, you will do it the same way you would any two fractions, which is multiply straight across the top, the numerators, and across the bottom, the denominators. So in this gray box, we've got a proper definition. For any fractions a over b and c over d, where b does not equal 0 and d does not equal 0. So notice that specification. Why can b not equal 0 and d not equal 0? Why are they specifying that? The reason is because those are in the denominator, and whatever's in the denominator, it's like you're dividing by that number. And we know you can't divide by 0. Try it. Take your calculator. Do any number divided by 0. It will not work. It will give you an error message. So the reason that says that is because you cannot divide by 0. Okay? And so later on, when we deal with rational functions and things, we'll talk about the restrictions because of that. So just making sure that whatever's in the denominator cannot equal 0, and finding the x values that would restrict, how that would restrict your domain. All right, so we've got a over b times c over d, and so notice they just multiply a times c on the numerator and b times d in the denominator. All right, and I've got some steps for you here. Let's fill in these blanks. First, we want to factor all numerators and denominators completely, so same as simplifying. Step 2 says to identify any restrictions on the domain. However, we have decided to save this one for later when we talk about rational equations, so you can ignore that one for now. We're not going to talk about restrictions yet. Step 3, you want to divide common factors of the numerator and denominator. So anything that appears in the top and the bottom, you can divide out or cancel. This includes factors that are diagonal from one another. Okay, step 4, multiply across the top and across the bottom. So you can do these steps in whichever order you prefer. You can switch those if you want. It doesn't matter if you multiply first and then divide things out, or cancel and then multiply. Just a lot of times it makes things simpler if you divide first, if you cancel factors out first, so that your multiplication is simpler after that. All right, so let's try number 5, and these will be our last few problems for this video. All right, number 5. So step 1, we want to factor the numerator and denominator. Yes, lots of factoring here. That's why we're doing this right after we finish our unit on factoring, because hopefully it's fresh on your mind and we get to use it a lot now. All right, so factoring the numerator and denominator. This first numerator, that's a difference of squares, so I'm going to do x minus 2, x plus 2. Our denominator here, this is going to be two numbers that add to -6 and multiply to -16. That's going to be 2 and -8, positive 2 and -8. Okay, my second numerator, two numbers that add to -12 and multiply to 32. So that's going to be -8 and -4. So this one should factor into x minus 8 times x minus 4. And finally, this one just has a GCF of 3, leaving us with x minus 8. All right, now we cancel or divide out anything that appears in the numerator and denominator, and this can be diagonal too. So if it's in the other fraction, but if it's in the numerator and denominator, you can cancel it, but only once. So I've got my x plus 2's right there, top and bottom. I've got an x minus 8. Now I've got it in this fraction on the left and I've got it in the fraction on the right twice. So it doesn't matter which one you cancel, just only cancel one of those x minus 8s in the denominator, not both. Okay, so just one of them. All right, now we're moving on to step 4, which is now step 3 since we canceled step 2. But we want to multiply across the top and across the bottom, so just multiplying what's left. That's going to be x minus 2 times x minus 4. And in the denominator, I'm left with 3 times x minus 8. I am going to go ahead and simplify that, so multiplying those factors in the numerator gives me x squared minus 4x minus 2x plus 8. And this is what I was talking about with you're going to have to be really efficient with FOIL. Distributing that 3x minus 24. And then lastly, I just want to combine like terms in the numerator, x squared minus 6x plus 8. Awesome. Number 6. So let's factor the numerator right here on number 6. If you wanted to, you could just write that above. That should give you x minus 2 times x plus 5. That was wrong. X minus 5. Two numbers that add to -7 and multiply to +10. And then this one I can factor out a 5, so x minus 4 is left. This one's going to take a little more work. So we're looking for two numbers that add to -4 and multiply to -12, a times c. So my factors of -12 are 1 and 12, 2 and 6, 3 and 4. Which ones? Well, I need them to multiply to a negative, so make one sign negative, and they need to add to -4. So that is going to be 2 and -6. So we split the middle guy up, that middle term. Then we factor by grouping. All right, so I'm going to go ahead and rewrite all of this out now that I have factored everything. So I've got an x minus 2 times x minus 5 over 5 times x minus 4 multiplied by x minus 4 over 3x plus 2, just getting this that we just factored, times x minus 2. All right, now we want to divide out anything that appears in the numerator and denominator. That would be x minus 2, x minus 2. Even though they're in different fractions, you can still divide those out. So x minus 4 and x minus 4. Sweet, so that leaves us with x minus 5 in the numerator, and then 5 times 3x minus 2 in the denominator. And you could go ahead and distribute that 5. And you're done. All right, this last one's a little different, and you'll notice that for some reason when I changed this to a PDF, the x went missing, but there should be an x there. So you're gonna have to write that in on your paper as well. Sorry about that. Okay, so when you have rational expressions like this one, where you can't necessarily factor it, they are monomials for each one. Like there aren't multiple terms in each one. I think it's actually easier if you go ahead and multiply across. So use your properties of exponents. How would I multiply 30x squared y to the fourth times 10x to the fourth y? I would multiply the coefficients, which gives me 300. And then I would add my exponents because I'm multiplying, so x to the sixth and y to the fifth. Same thing in the denominator, so multiplying 5 times 6, I get 30 x squared y squared. So I think that's a little bit easier than actually like factoring all of these numbers and then canceling, because now we can just simplify this one rational expression. So 300 divided by 30 gives us 10. Remember, when you're dividing, you're going to subtract exponents on like bases. So 6 minus 2 is 4, x to the power of 4. 5 minus 2 is 3, so y to the power of 3. So I think that's a little easier than trying to go in and factor everything. All right, so that's it for this video. We'll continue these notes in part 2.